Hello everyone, welcome to my channel and we have a new circuit here. This one is our new circuit. This is Optocoupler buffer gate, and this circuit is the combination of this circuit and this circuit and this circuit. Three circuits combined to form this Optocoupler buffer gate. This other circuit is also an optocoupler circuit. But the difference between the two is it has only one power supply and this has two power supply. So the purpose of this circuit is how to use optocoupler to isolate the two circuits and as a buffer gate. Let's see the circuit diagram. The circuit diagram of this is this optocoupler buffer gate. We have the 5-volt supply, and also we have this 12-volt supply. And the 12-volt supply is the LED in series. And then we have the optocoupler at the center, and we have this one, an LED with a push button. That is our previous circuit, that is a resistor buffer gate. And we also have this diode circuit. This one is also a diode circuit. As you have seen here, it's already the lighting showing that's a diode circuit. So this is the circuit diagram having two power supply here. When you push the button here, the LED is lighting. At the same time, the LED on the 12 volts is lighting. Because when the current flows here, when you push the button here, you close the switch here, the LED turns on, push the switch, current flows here to the LED inside the optocoupler, lighting the LED, making the phototransistor to activate, making this LED in series to flow the current to the ground, activating this phototransistor by means of this LED coupler or LED inside the optocoupler, light emitting LED here, sort of emitting diode here that activates the phototransistor, making the LED to flow the current into the ground, since this is 12-volt supply. So this we have given here the voltage rating of the LED is 2 volts, current rating is 0.2 ampere, and we have this voltage forward or input voltage of the optocoupler is 1.2 volts. That is the voltage input, voltage rating of the optocoupler, 1.2 volts. And then we also have this current rating input of 50 milliampere. So it is capable of handling 50 milliampere current input and voltage input of 1.2 volts. So using the Kirchhoff's voltage law to find the resistor to protect the LED, at the same time the optocoupler, we now get this 3 volts voltage drop across the resistor. Using Ohm's law, we have 150 ohms, but I use 220 ohms. And then This is for the LED here. Now for this loop, this is for the LED here, RD1 to 20 ohms. Now this for this loop, using KBL, voltage supply minus voltage that RD2 minus voltage drop at the optocoupler, which is 1.2 volts here. We get 1.8 volts voltage to protect the optocoupler and the diode. We now have 90 ohms or 100 ohms available. And since this is buffer gate, we have a truth table. No input, no output, with input, with output. So that is buffer gate. We have the parts here. We now have the complete parts here, including the values. Also the layout. And this, we have a new header here. You can replace the input by patching. There is provision for patching here. This is our new feature in our project, a new header design. Just like here, you can patch here. You can replace it with other output. Also this one, from here to here, this portion, by using this header. So that's it. That's our new circuit, and our mission is to, since this is a combination of 3 circuits, our mission is to use this optocoupler to isolate 2 circuits. We are successfully isolating 2 circuits here, the LED in series circuits and the LED here, circuits here. They are electrically isolated. What the means of their connection is just by the light emitted by this light emitting diode to the phototransistor, and that conducts this phototransistor into saturation mode, making this LED to light, to have a closed circuit here. So we calculated the values here for this first equation, Kirchhoff's voltage law, and also here. So we successfully protecting the optocoupler from destroying this optocoupler, and we successfully make the circuit a buffer gate. It means that whatever is your input here becomes your output. I think if your input here is blinker, also here it will blink the LED. This is the input, these are the outputs. And that's it. That's a combination of circuits using as a buffer gate, and we are successfully isolating 2 circuits, high powered circuit, high level circuits at the right side, and low level circuits at the left side, 5 volts and 12 volts. Thank you for watching the video. Bye bye.